So, Bismillah, Assalamu alaikum wa rahmatullahi wa barakatuh. Today, inshallah, we are talking about the extrema and the average rate of a change. So, at the first, we'll start with the increase and decrease and the constant, how we can understand the function. You remember when we talk about the end behavior? The end behavior of the function, we have to divide the function. We have to divide the function into two parts. So the first part, which is the left part, and the right part. At the left part, you will find that the function is going down, and the right part, the function is going also down. So that's the meaning of the end behavior. How we can translate that into mathematical expression. Now for the increasing. If you look at the graph, you will find that if you want to read the increase and decrease for any function, we start reading from left to right, not from right to left. We have to read from left to right. So if you look at the graph now, you are going up. The graph now is going up. It means it's increasing. Then it's going in a horizontal line. It means that's constant line. Then it's going down. It means the graph now is decreasing. So how we can read and increase and decrease for the function? At the first, as we said, we start from left. So what is what we have here from left? We have arrow. It means we are going to negative infinity. So we start from the negative infinity, the first part. We are going from negative infinity to the number which is opposite to negative 5. So that's the first part. From negative 5. Yeah. Negative infinity is open, and negative, if you find any critical point, the point that's changed the graph from increasing to decreasing or to constant, at this point, the graph must be open. And we know that negative infinity is always open. So at this part, the function is increasing. Then we have another situation that we have now, which is the constant. This constant starts from negative 5 and end at 0. So we can say that from negative 5 to 0 we have constant. Then again, starting from 0, then becomes to be decrease. Decrease, and if you look at the graph, you will find that the graph is going to the right. Going to the right, it means going to positive infinity. So from 0 to positive infinity, it means we have increasing. Any problem for this one? You know how we can read the graph now? Okay.
Wait, the last one, is the last one increasing or decreasing? It's going down.
Sorry, this one is decrease, not increase. Decreasing. Okay. So for each graph, we need to revise. I will start. I need only the increase and decrease, but we will start from the end behavior. Then we continue with the increase and decrease. So what is the end behavior for question number 1? Question number 1. The end behavior?
From when f of x is negative, positive infinite, when x is going to negative infinite.
So we can say that limit when x is going to negative infinite, the approach should be negative infinite. The function
is going to infinity.
Is going to positive, and its approach should be positive infinity. And limit when x is approached to be positive infinite, the function is approached to be negative infinite. That is the end behavior.
Sir.
Yes.
So you can write infinite from the left side, like with a negative sign. Will this mean negative infinite?
Sorry?
Like if you put infinite and then the top right is a negative sign.
Why you want to change anything?
No,
What's your name? What's your name? What's your name? What's your name?
Omar.
I know that you're Omar. I will write Omar by this way. Plus? Okay? That's your name now. That's your name. Don't write your name by any way except this way. I will not accept any way for you. خلاص? So the second one, we need now to read the increase and decrease for the function. How we can read the increase and decrease for the function?
Y value. You check the Y.
Sorry? The function now is increase or decrease?
Increasing.
How increasing?
It's decreasing, it's going down.
It's going down.
Which side?
How many times I said if you want, Shafai, that's not the first time for you. When I ask you, please, if you want to read the function, read it from left to right. Is this right?
Yes.
So from left to right, did it increase? I say, if you remember last year, we stay more than 1 hour to inform you that you have to read from left to right.
Yeah, I remember.
You remember this?
Yes.
Okay, I will write Shafai from the other side. Function is you have to read it from left to right. So you insist you read from right to left, your answer is right. Write your answer that you have to read it from right to left. No problem for me. Your answer is right. Write it. Leave Shafai, خلي ولي Shafai. Just look at the graph here that we have. The graph now, we will read this function is increase or decrease?
Decreasing.
Decreasing. Decrease from the beginning to the end. From the beginning to the end. It's mean from the beginning. What we find from the beginning?
Negative infinity.
Negative infinity. And from the right side?
Positive.
Positive infinity. No.
Negative.
Look at x to read the function.
Y or X?
X. Like the domain.
Okay, yeah, negative.
What is the meaning of decreasing and decreasing for the function? You look at which interval for x the function is going up and down. Again, for this part, to understand what is the meaning of increasing and decreasing. If you start from, because y is depend on x, is that right? The function is depend on the value of x. The function is depend on the value of x. So if you look at x, what will happen to the function? If you look at x, the function is decrease. So now, which value of x the function is decreasing? At which interval the function is decreasing? The function is going down. So just looking to the x, at which value of x the function is going down. You understand it? Like the domain.
Yeah.
So when you want to read the end behavior, you start from at the left side of the function is going up. At the right side of the function is going down. So at the first, you read x. According to the value of x, according to the left side of x, the function is going up. According to the right side, the function is going down. So that's how we can read the function. So for increasing and decreasing also, at which interval for x, the function is going up or down, increasing or decreasing. So it's decrease from the beginning to the end. Beginning of what? Beginning of x. What is the beginning of x? Beginning from negative infinity to the end, which is positive infinity. So that will be open and that will be open. Shafa, if you want to write it increase, no problem. You can write it, no problem for me. Khalas?
Mr. Islam, I said when the x values are approaching to the negative infinity, the function is going towards the positive infinity. That's
Again,
what I
for
said.
this part. No. I'm talking about increase. Well, you didn't talk about the end behavior. I'm talking about the increase.
Yeah, I talked.
Increase. The function is increasing or decreasing. The graph. There is a difference between the end behavior and the graph. If you remember last year, when we stay more than 1 hour to read if the graph is going up or going down.
I remember that. I remember
okay,
that.
That's good.
I was talking about something different.
So my question was about what? About increasing or about the end behavior?
Decreasing.
So that's the answer for decreasing. What's your name? 16 years old. That's the same. Is that right? My question about the increasing and decreasing, because we are wasting a lot of time last year about this point. I remember. So there is some points here for me, no problem wallahi for me to explain anything, to repeat it more than 100 times. But to insist about the mistake, khalas, no problem, you can read it, no problem. As I told Omar insists that any solution, when I write anything, it just want to sweep the answer. خلاص, sweep the answer, no problem for me. So the same here. We need to read the end behavior for question number 3. The end behavior. What is the end behavior?
When x approaches negative infinity,
Yes.
f of x.
When x approach to negative infinity, f of x
is positive infinity.
is positive. And the second part, when x approach to
Positive infinity.
okay,
Infinity.
positive infinity,
F of x is
f of x
Positive
is
infinity.
approach to positive infinity. That's what? That is the end behavior.
Yes.
Now we are talking about the increase and decrease. So look at the graph. You will find that the graph is two
Decreasing and
parts.
increasing.
Decrease, then increase. So that's the first part. And that will be the second part. So we start reading now. Just 1 minute to open. Suhaib, there is 2 Suhaib. MashaAllah. Okay. So we will start reading now for the function. The function starts from increase or decrease. I will start from left here, then going down. So it will be decrease. So decrease.
From negative infinity to negative 3.
From negative infinity. We start from the end, from negative infinity. Then we are going. So at this point, the function is turning to be increased. What is the value of this point on x-axis?
2.
2. So just read for x, not for y. Then, again, after that, the function is increase.
From 2 to positive.
From, starting from 2. At any point, at any critical point, at this point, the function must be open. The function must be open. To be open. Any problem for this one?
Yes, sir.
What's
what
the
about
problem?
the other one?
Which one?
You know how
Number.
you wrote, no. The number 1 question, you didn't
Number
write
1.
a number.
Because it's a decrease from the beginning to the end. It's continue decreasing.
But if it has a turning point, you have to write the
But yes,
point where you turn.
there is no turning. The turning point here just to change the rate of decrease. You understand? It's still decreasing. Yeah. It's going down. Then again, just take a slowly turning. Then again, turn down again. But all cases, it's still decreasing, still going down. But with different speed. It's not constant.
It looks constant.
It's look, but it's not constant. You know what is the meaning of constant? It's mean if you replace x equals 1. For example, x equals 1, you find that the value of the function, for example, equals 5. X equals 2, the function still equals 5. X equals 3, still the function also equals 5. Did you, if you change the value of x, did you get the same answer here?
No.
By changing the value of x, the function will be changed. Because there is no constant number. Because there is a value here for x. You understand it? Constant, that's happen only if you have a piecewise function. If you remember the piecewise function. For example, when I say, just a minute to erase this part. When I say the function, the piecewise function, f of x equals, I will say here, 3x plus 5, and that's 2, and that's x negative x minus plus 4. So if you look at the slope here for the first one, you will find that the slope now is increasing. Now the function, there is no x and there is only one number. It's mean constant function. It's represented by horizontal line. Now the slope here, the rate of change is negative. It's mean decreasing line. You understand? When you find only constant, if you have a number, at this number you will find a constant function. And the function is defined when x, suppose that x is smaller than 5, when x is greater than 5 and greater than or equal to 5, and smaller than 10 when x is greater than or equal to 10. You understand? That's the condition for the function, for example.
So it can only be constant if there's no variable.
Sorry?
So it can only be constant if there's no variable.
Yes, if there is only one number for the function, that will be constant. That's the meaning. That's the meaning of constant function. Yeah. If you remember the constant, the graph for the function, when I say f of x equals x. That's defined by linear function represented by line. F of x equals x to the power 2. It's mean parabola. But when I say f of x equals 5, it's mean constant straight line. So that's the only case that you will find a constant.
Okay.
You get the idea? There is someone is asking here. Who was asking?
Me, sir.
Who? What's the question?
Sir, can you explain again the third one?
Which one?
Third.
Number 3? Okay.
Yeah.
Again, for number 3. Again, I will erase this part and I will write it here. Again, for number 3. Which part that you need me to explain it?
Sir, I don't understand decreasing and increasing.
The function now, if you look at the from left to right, what will happen to the function? From left to right. From left.
Function is increasing.
Are you sure the function is increased? So we can make no problem. You can come on Saturday at the school and I will be at the school to explain it to you. No problem for me. But you are insisting about this point. Wallahi, no problem for me. I will not waste time at this time to show you from left to right. That's the arrow is going down.
But sir, it shows there it's going up.
Khalas, no problem. From left to right, the arrow is going down, up. Khalas, no problem for me. I'm wasting 1 hour last time. I will not waste time today for life for showing that. From left to right, the arrow is going down. From left to right, we read the English. From left to right or from right to left?
That's right.
Type, khalas. This is the graph also will be the same from left to right. From left, the graph now. If you want to graph, I will graph the function now from left to right. When I'm graphing now, my hands is going down or going up?
Down.
It's mean increase or decrease?
Decrease.
Khalas. That's the idea for increasing and decreasing. Start graphing from left to right. No graph, we didn't start. If you want to write your name, how you write your name? Give me the letters, please.
S-H-A.
S-H-A.
F-A-Y.
F-A-Y. Okay, that's the name. That's right?
Yeah.
We start from right, that's right. Did we start from right? From left?
No. Yeah.
You write your name by this way?
No.
Why?
Because it starts from left.
But I like to start from right. تأمنوا. I like to start from right. But there is rule to write. Is this right? There is rule to write the names. There is rules to write the letters. Is this right? What is the rule? Well, I let you to understand. What is the rule to write?
From left to right.
From left to right. S-H-A-F-A-Y. That's right?
Yes.
So that is the rule. The rule for drawing a function, you have to start drawing from left to right. If you start from left here, what will happen? Your hand is going down or going up?
Down.
Khalas. It's mean it's increase or decrease?
Decrease.
Don't ask me the same question because last year, wallah, I reached to the same point and you say I am not, I don't understand why that's the increase and decrease. So that's my answer. If you have any other answer, wallah, I don't have any other answer.
Okay. Mr. Eslam, what's 2 there? Is it y-axis or on x-axis?
Which one?
The 2. 2.
2 for x. 2 for x. We just read y is depend on, you say the function is increased. Now, we have 2 properties now. One for x and one for y. Or 2 conditions now for one for x and one for y. Y, which is the function. So you say that the function is increase or decrease? Is increase. Y is depend on what?
X.
X. So what you said that y is increase when x is from negative infinite to positive 2. Because we are going from left to right. So left to right, it's mean x or y? You say, what is the meaning of increase and decrease? When I ask you to graph, it means your hand is going up or down?
Down.
Down. Down, it's mean x or y?
Y.
Y. Y, it's mean that's for the function. So for the function, my hand is going down. At which part? If I start from negative infinite, I find the number 2 on the graph. Then at 2, the function is going up. My hand is going up. That's the meaning of increase and decrease.
So that too was
mean-
on y-axis, right?
It means, just 1 minute, if you have a number line here, you have x1, x2, x3, x4, x5. At x1, the value of the function, that's f of x1. At this one, that's f of x2. At this point, f of x3. At that point, that's f of x4. At this point, that's f of x5. Now we can graph. That's the first point, then I'm going down, then horizontal line, then again I'm going down, then I'm going up. Now if you want to read, x1 is greater or smaller than x2?
Greater.
x1 is greater than x2? A number at the left on the number line is greater than the number that at the right?
No, it's smaller.
Smaller than, alhamdulillah. x2 is greater than or smaller than?
Smaller than 3.
Smaller than, alhamdulillah. x3?
Smaller.
Smaller than. x4?
Smaller.
Alhamdulillah. Now the graph is going down or up? Your hands going down or up?
Decreasing.
Decreasing. We are going down. Is that right?
Yes.
Okay, it's going down. How? At which interval?
x2.
At this interval. No, at this interval. From x1 to x2, at this interval, the function is going down. Then you have another interval here. The function is going horizontal. It's constant. Start from x2, end at x3. So now we have another one, which is horizontal. At which part? When x2 and between x2 and x3, between x2 and x3, the graph is horizontal. Between x3 and x4, the graph is going down. Between x4 and x5, the graph is going up. So you just, what is the value? At which value of x, the graph is going up and down? At which value of x, the graph is going down and the graph is going up? That is the meaning of increase and decrease with an easy way. At which value of x, the graph is going up and down. That is the meaning of increase.
Clear.
Okay. So for this one,
Increasing.
we need to read the end behavior at the first. End behavior,
X is negative.
when x tends to negative infinite, the function
Is
negative infinite.
negative
infinite. When x tends to
is
positive infinite,
infinite.
at the right side, the function
It's going to put positive.
going to
Infinite.
positive infinite. Okay, that's what? That is the end behavior. Okay, we finished the end behavior. Now for the increase and decrease. So we can read. How many parts that we have? We have how many parts?
3.
3. That's
3.
the first part. Then again we have another part. Then again we have, that's the third part. This part, the yellow one, I will start from here, then going to the left. And the orange one, starting from here and end at this point. Is that right? And that is the yellow one. Start from here and going to the right.
Yes.
You understand? Just look at x-axis. Draw a line on x-axis. So now, starting from negative infinite to this number. What is this number? Is negative 2. Then, what is the value of this number? Is positive 1.
Positive 2.
Going to the
Positive
end,
1.
to the positive infinity. Now we need to read. The function is increase or decrease from the first one? Increase or decrease?
Increase.
Increase. Start from increase. From which interval? From the yellow one. From which interval? From
Negative
negative
3
infinity
to.
to
Infinite
negative 2. Then
But how's
the
it negative
function,
2 though?
this one, you just look again for this part. How you know that's negative 2 and negative 3? Again for this one. You find that the graph is going up. Then at this point, the graph is stopped and going down. There is turning point. Is that right?
Yeah.
So you go
Yeah.
back, go down to x. What is the value of this one? That's -1, not -2, sorry. That's -1.
Yeah, that's why I was confused.
That's -1. Okay? Then, after that, the graph is going down. At which number?
+1.
At 1. Then, again, the graph is going up
From 1 to infinity.
from 1 to infinity. And here from -1 to -infinity. And at this part, the function is decreasing. For any value, if you choose any value between, again, to understand this one, if you choose any number between -1 and 1, choose any number, choose, I need 4 numbers between -1 and 1. Arrange it from smallest to the greatest, starting from -1 to 1. Suppose that -0.5,
0.
0.5. خلاص, no, that's enough. 0.5. Can you substitute for the first value? 0.5. Use a calculator to substitute by substitution. 0, -0.5, -0.5 to the power 3 minus 3 times -0.5 equals. The answer is 1.375. Is that right?
Yeah.
Okay. Now we choose 0. So the answer would be 0. That's right?
Yeah.
Now we change it to be 0.5. Use a calculator, please, to understand what I'm writing now. The answer is -1.375. Is that right?
Yeah.
By increasing the value of x, because if you write any interval, you write from the smallest to the greatest. By increasing, what is the meaning of direct relation and the inverse relation? Direct, by increasing the first one, the second is increase. Inverse, by increasing the first, the second is decrease. Is that right?
Yes.
That is the meaning of increase, direct and the inverse. So direct, it means both of them are increasing. X is increase and y is increase. But inverse, x is increase and y is decrease. So at this interval, starting from -1 to +1, you will find that the value of the function at each time, you will find that the function is going down. It means it's a decrease. You understand now what is the meaning of that algebraically? If you choose any number between -1 and 1, then going in pattern by this way, you will find that the function in each time it's going down. It's decreased. The value of the function is decreased. But if you choose any value from -infinity to -1, you will find that the function is going up. The value of the function is increased. You understand now? What is the answer that you will find from the function? The answer that you will find from the function is increasing. At which interval? When you replace the function, when you replace x from -infinity to -1. But when you replace x from -1 to +1, you will find that the answer from the function is going down, is decrease. But when you place x from 1 to +infinity, we choose any number from 1 to +infinity, you will find that the value of the answer is going up. That is the meaning of increasing and decreasing of the function by another way. Is it clear now?
Yeah.
So decrease from -1 to +1. Then again increase
from 1 to
from 1 to +infinity. So number 4, we need to solve question number 4. If you look at number 4, you will find that we have a constant part. Is that right?
Yeah.
You will find
Yes.
that we have here, for the piecewise
Constant.
function, a constant value. You understand it?
Yeah.
So now we have, at this part, the function is increase or decrease?
Increase.
Increase from
Increase.
negative
Negative
infinity to
3.1.
which one?
3.1.
No. Look at the
Well-
graph here. Look at the graph.
No, but if you look at the
Yes,
function,
3.1,
Negative
yes. It's a 3.1. No. Look at the condition that we have here.
Oh, yeah.
It's a 3.1. Negative 3.1. Then, from 3.1, you will find that the graph is going to the right.
Continuous.
Constant.
So it's mean the function is increase
And then constant.
from negative infinity to negative 3.1.
3.1.
Then
Then
constant
negative 3.1
from
to positive 0.2.
negative 3.1 to positive infinity. So who can read the end behavior for this function? The end behavior.
F of x is
When x,
negative
just 1 minute, when x
infinity.
tends to negative infinity, when x tends to positive infinity. What will
First
happen for
one
the
is
function? What will happen to
negative
the
infinity.
function?
So
First
negative
one,
infinity is
negative
just
infinity.
negative infinity.
Yeah, negative.
And for
Okay, this one will be negative infinity.
and for
And
this f of x equals to whatever the value of y is.
what is the value of y now?
Sir, can I say in terms of limit?
This one,
1.7.
yes, you can write in terms of limit, no problem.
1.7.
1.7, because that's the value of the function. That's 1.7.
Right.
So 1.7.
So
Because
f
that's
of
we
x
have a
is-
horizontal line. So just look at you need to know where the value is going. So you look at y. What is the value of the increasing, the value of the x? You just look at the x-axis, not the y-axis. The domain, you look at x. The range, you look at y. The reason, you look at x. After that, what will happen? The answer that you will get from y-axis. Okay. Any problem for this part?
No,
Okay.
No, I don't get how. I don't get it.
Which part?
Right.
Which one?
Where you got the negative 3.1 from?
From the condition here, from the piecewise function.
Oh, because
From
the
the
square
condition.
was covering the one. Yeah.
Now, what is the meaning of the critical point? The critical point for the function, that's the point. If you find that that is defined by the horizontal line. At this point, there is a horizontal line, it's tangent to the curve. And because it's tangent, you will find that the curve is increased, then become decrease, or decrease, then it's going to be increase. So the line could be vertical or horizontal for the graph. The extrema at this point, you will find that the extrema for the end behavior and the point, the maximum point and the minimum point. The maximum point is the highest point at the graph, and the minimum point is the lowest point at the graph. So that's what we need to know. The point of inflection, that is the point that if you find that the graph is going down, then again going down, but with different rate. With different rate, at this point, there is a point here. Okay? That is the maximum point, that is the minimum point, and that is the point of inflection. Inflection point. So now we have the maximum and the minimum point. We have the absolute point and the relative maximum point and the relative minimum point, the absolute maximum point and the absolute minimum point. What is the difference between them? When I just say the maximum point, that's defined by the highest point at the graph. The minimum point, the lowest point at the graph. If you just talk about this interval from 0 to this point, suppose that we have here x1 and x2. At this point, at this interval, that is the highest point at the graph. Is that right?
yes.
So this point defined by the relative maximum point. But for all of the function, that is the maximum point. So that's the absolute maximum point. You understand it? So at A, when x equals A, there is relative maximum point. But when x equals B, there is absolute maximum point. You understand it? So for this one, we have here, that is the minimum point, only when x start from x1 and x2. We have only relative minimum point. But the minimum point at the graph, which is when x equals b, that is the absolute minimum point at the graph. You know the difference between the minimum and the maximum point now?
Yep.
Okay. So if we have a graph like that, what is the type of the point that we will find? Maximum, minimum, which type of maximum, which type of minimum point?
Will we find the maximum?
Absolute minimum.
There is no absolute minimum.
We'll find relative
Maximum and relative minimum, but there is no absolutes. Why there is no absolute minimum?
Because
the graph is going down, and the graph is going down. The graph is going up. It means there is no absolute maximum. Again, for this one, for the first graph here, the two end behavior are going down. It means there is no absolute minimum. But for this one, the two end behavior are going up. There is no absolute maximum. There is no absolute maximum. You understand it? If one of the end behavior are going up, it means there is no absolute maximum. If one of the end behavior is going down, it means there is no absolute minimum. You understand it? Is that clear?
Yes.
Yeah.
Okay. We need to read all what we studied before. The end behavior, the increase and decrease, then the extrema, the maximum, the minimum. So for number 5, the limit, the end behavior, sorry.
When x approaches negative infinity, f of x approaches negative infinity. When x approaches positive infinity, f of x approaches negative infinity.
Yes. At the left side, the function is going down, and the right side of the function also is going down. So both of them are negative, okay? So now we need to find the increase and decrease.
Yeah.
We need the approximate value for this one, not the exact value.
It increases, then decreases.
It's increase, then decrease, then increase, then again decrease. So it's increase at which part? That's what we will see. That's it, the first one point, and that is the second one. That's it, the third one. We will round it, an approximate value for this one. So at this point, it's approximately negative 1.5. This one is approximately negative 0.5. This one is approximately 1.1 or 1. So how we can represent that?
From negative infinity
it's an increase from negative infinity to negative 1.5. Then decrease
Negative
from
1.5
negative 1.5 to
1.
No. At this
To
point,
negative 0.5.
0.5. Then it's increase from
Negative 0.5 to 1.
there is noise here.
Abdurrahman's mic, I think.
Okay. Then increase from
Negative 0.5 to 1.
negative 0.5 to 1. Then again going to be decrease from 1 to negative positive infinity. Positive infinity. Because it's going to the right.
Yeah.
Okay. So that's the increase and decrease. Now we need to find the extrema, the end behavior, and the.
It has. Do we also count relative maximas?
Yes. Count all what you will find. Okay. All of the extrema that you have.
It has one maximum, absolute maximum, one relative maximum.
Okay, we have relative maximum at
0.
X equals 1.
X equals 1.5.
Relative negative 1.5. And we have absolute maximum at X equals 1.
1.
And we have this point is
negative 0.5.
Relative minimum.
Negative 0.5.
when x is equal to negative 0.5. There is no absolute minimum because the two end behavior are going down. It means the function is still going down. There is no minimum value for the function. You understand it?
Yes.
Okay. So we can represent this one also, the increase and decrease. Let's say increase, then decrease, increase,
And decrease.
decrease, then again increase. So we can represent the point here. That's the point. It's about 1 point, negative 1.2, approximately 1.2. Sorry. This point is negative 1, and this point is 0.
0 to 0.
And this point it's about 0.5. And this point it's about to be 2. So how we can represent that?
So from
That is the first part. That is the first part. Then that is the second one. Again, that is the third part. Then that is the fourth part. Then that is the last part. You understand how I just make different colors to differentiate between them. So the first part, which is negative infinite to negative 1. Then the next part is, we know that's the increase and decrease. You understand that?
Negative 1 to...
From negative 1 to 0. Decrease. That's increase. That's decrease. Then again increase. From
0 to 0.5.
0.5. Then again we have decrease from
0.5 to 2.
2. Then again we have increase
2 to positive infinite.
2 to the positive infinite. Okay. Now you know what is the meaning of increase and decrease? We need to study the extrema.
Okay. Relative maximum
At
negative 1.
Negative 1. There is only one. That is the highest point at this interval only. At this interval. So it will be relative maximum when x equals negative 1.
Yeah.
And
relative minimum.
Relative minimum
X equals
when x equals
2.
2.
Almost 2. Yeah.
Yeah, almost 2. Yeah, that's about 2. You understand it?
Do we also count the other relative maximum?
No. I just need one relative one.
Okay.
Okay. You understand it? There is no absolute maximum. There is no absolute minimum because one of the end behavior is going up and the other part is going down.
Yes.
Any problem for this one?
No.
Okay. So for the last one?
Increasing, decreasing, then
increase. And then increase. And we have here, there is a decrease.
From negative infinity to...
So just write the numbers. Write the numbers here from
negative 0.5.
And this number is about to be 1. So we need to divide the parts here. Just a minute to divide the parts. The yellow for the increase and the orange for the decrease, okay? So now we have increase from
Negative infinity
to negative 0.5. Decrease from
negative 0.5 to 1.
Increase again from
1 to positive infinity.
1 to positive infinity. Okay. Now for the extrema.
Relative maximum and minimum at 0.5 and 1.
How?
We have here, that is the highest point at this part only, at the critical point. At this point, the curve is going from up, then going down. So that is the highest point. So we have relative maximum at x equals negative 0.5. And we have here relative minimum at x equals 1. Any problem for this point?
No.
No.
You know the difference now between them? Is there any problem for this part? I can explain it more. Is there any problem for this part?
Just
Which one?
the last part.
Which part? Which one? And just give me the name and I explain it.
The R minimum.
The relative minimum and the relative maximum?
Yeah.
At a part of the graph, what is the meaning of relative maximum and relative minimum? You know the critical point? The critical point. At this point, the graph it change its figure. The graph is going up, then it's going down. Or going down, then going up. then at this point, we just need to know if this point is maximum or minimum. You understand it? You
Yeah.
understand the meaning of the maximum and the minimum? Please, Yani, just open the mic, wake up, just give me the response, please, to finish this point. No problem to repeat it, but just don't leave me, okay? Okay. So at the turning point, there is we can count here the maximum or the minimum. According to the position, we have two types of maximum, two types of minimum. For the first one, the first type of the maximum, we have the absolute maximum and relative maximum. What is the difference between them? The absolute maximum, it means that is the highest point at all over the graph. We count the highest point for the turning point. Turning point must be turning point. Turn from increase to decrease. That is the meaning of the turning point, the maximum or the minimum. Are you understand this point? Is it clear?
Yeah.
Okay.
Yeah.
So if this point here, you just counted for a small part of the graph, it's called relative. If that is the highest part of the graph, it's called absolute. What is the difference between them? The two end behavior of the graph now are going down. What is the meaning are going down? It means there is no minimum point for the graph. There is no absolute minimum. Because if you continue going down, the graph will decrease. The value of the function is going to be decreased. It means there is no absolute minimum. When we don't have absolute minimum, if one of the side of the graph is going down, it means there is no absolute minimum. When the graph is going up, it means there is no absolute maximum. But we have relative maximum, but we have absolute relative maximum and relative minimum. What is the difference now? For this one, we have relative minimum, relative maximum, and the absolute maximum. That is the highest part at this interval only. But that is the highest part at all over the graph. This point is the relative minimum, but there is no absolute minimum for the graph number 1. For graph number 2, because the two end behavior are going up, it means there is no absolute maximum, but there is relative maximum. There is relative here, relative minimum and absolute minimum. So for the graph number 3, one of the end behavior is going down, it means there is no absolute minimum. One of the end behavior are going up, it means there is no absolute maximum. But still we have turning point, two turning point. At this turning point, that is the highest turning point at this interval. And that is the lowest turning point at that interval. So that's the relative maximum and that's the relative minimum.
Yeah.
Any problem?
Shukran.
Okay, Habib, welcome. You remember the rate of change? Rate of change. What is the meaning of the rate of change that you know?
x2 minus
x2 minus x1 or y2 minus y1? Rise over run. The rate of change defined by the change of y over the change of x, which can be written as y2 minus y1 over x2 minus x1. If you want to talk about the average rate of change for the function, all what you have to do, what is the difference between the equation? Yes, the slope. What is the difference between the equation and the function? In the equation, we said that y equals 3x. But for the function, we just replace y with f of x equals 3x. Is this right?
Yes.
So all what you have to do just to replace y with f of x. So to find the rate of a change now, or the average rate of change over the function, f of x2, that's mean y2, minus f of x1 over x2 minus x1. How we can find it? The question that we have now, find the average rate of change for f of x equals negative x bar 3 plus 3x for each interval. That's x1 and that's x2. All what you have to do, just we need to find f of x1. What is the value of f negative 2? That's f of x1. You understand that? F of negative 2, which is equal to, again, I will write it here. I will write this one. F of x1, which is, and instead of x1, what is the value of x1? Negative 2. So I will replace it with negative 2. So it will be negative of negative 2 to the power 3 plus 3 times negative 2. What is the answer? Use a calculator, please. That's
Negative
negative 8, positive 8. Sorry?
I said negative 1. It's 2. The answer is 2.
2. That's negative 8, and negative it will be positive 8. Minus 6, it will be 2. Now we need to find f of x2. What is the value of x2? Which is f of negative 1. So it will be negative 1 to the power 3 plus 3 times negative 1 equals
negative 4.
sorry?
Negative 4. So I got negative 4.
How negative 4?
How about negative?
It's negative 2. Negative 2.
Negative 2.
I got negative.
Negative 2.
I got negative 4.
Please use a calculator. Please write the value without any change. Write it inside the brackets.
Oh, okay. I thought it's negative x. Got it. Okay. Yeah, it's negative 2.
So now you do.
So now we need to find the rate of
-2.
a change, or the rate, which is f of x2 minus f of x1 divided by x2 minus x1. That is the formula. What is the value of f of x2? Negative 2 minus 2 over x2, which is negative 1, minus negative 2, which is plus 2. So the answer would be negative 4 over over 1, which
4.
equals to, sorry?
Just negative 4.
Negative 4. Any problem for this one?
No.
The rate of a change, that's only the rate of a change. Okay? So because I have another session now, so I have to go. And is there any problem? Is there anything that is not clear?
No.
Could you finish this lesson?
No, sir.
Okay. Assalamu alaikum.